When Eicma opens its doors in Milan this November, over 500,000 visitors will walk past displays from 730 exhibitors. They will look at thousands of motorcycles, each presented as a complete, perfectly engineered product. But every single one of those stands is selling an illusion. Not a single motorcycle on that floor is a finished machine. Look at a fluid dynamics visualization for a car, and you'll see a closed system. The occupant inside is sealed cargo. They contribute absolutely nothing to the exterior form or the aerodynamic math. A motorcycle places the human directly on top of the object, completely exposed to the destructive airflow. It is the only mainstream vehicle that leaves the factory as a fraction of itself. Designers spend years calculating how a machine will behave, yet they are blind to the physics of the final product, because they are not allowed to specify its largest structural component, the rider. This spatial relationship between the handlebars, the seat, and the foot pegs is known in the industry as the rider triangle. If you read marketing materials or listen to reviews, you'll hear this geometry discussed almost exclusively as a comfort metric. They talk about elbow bend, wrist strain, and how your knees will feel on a long ride. Look beneath that comfort, and you find a rigid engineering discipline called mass centralization. Engineers fight for every millimeter, moving the heaviest rotating internal parts closer to the bike's dynamic fulcrum so it can change direction with less effort. Teams will redesign an entire engine casing just to relocate a crankshaft by a few centimeters and shave off a tiny fraction of weight. Then they hand that perfectly balanced chassis over to a massive, shifting, unspecified human weight that sits high above the centerline and shifts under braking. The math of mass centralization cannot actually work on the machine alone. Data acquisition practice is entirely explicit that a resultant center of gravity can only be treated as the rider and vehicle combined. Treating the triangle as a simple ergonomic feature hides its true function. It is the geometric mechanism that dictates the vehicle's entire gravitational behavior. The physics get even more complicated when the machine starts moving. A standard motorcycle has a drag coefficient roughly double that of a modern car, running anywhere from 0.5 to 1.0. This diagram shows exactly why those numbers fluctuate so wildly. The true aerodynamic variable isn't the shape of the fairing or the chassis. The variable is the posture of the rider's spine. When a rider crouches behind the fairing, the combined frontal area is barely larger than the bike itself. Sit upright, and that area expands rapidly. A single machine possesses two entirely different drag figures based purely on what the human atop it decides to do. For over a century, the internal combustion engine acted as the central packaging anchor. Because of its massive bulk and fixed shape, designers had to place it first, wrapping the rider triangle entirely around the engine. The shift to electrification offered a rare, historic opportunity. Removing the engine meant removing the anchor. Designers could finally specify the rider first and package the powertrain around the human body. Instead, the industry moved towards cell-to-pack architectures. Massive battery casings evolved from dead weight into load-bearing structure, acting as the rigid skeleton for machines like Honda's WN7 concept and the newest generation of trellis frames. The anchor was swapped, not removed. By replacing the engine with a battery pack, the industry perpetuated a century-old design hierarchy, ensuring the human body remains a compromised, late-stage afterthought. Manufacturers try to solve this by offering low seats from the catalog or factory-adjustable pegs, treating the rider triangle as an accommodation to fix later. But the triangle is a concept phase decision. Lock in those 3 points, and you have permanently locked in the combined center of gravity, the aerodynamic envelope, the tank volume, and the frame's hardpoints. The highest-performing machines at Eicma will be the ones where designers confronted this harsh reality early. They fought over the foundation of the triangle while it was still an argument, rather than waiting until it was a weldment. You have to see every angle before you build. Design decisions are cheap when they are just a sketch on a screen. Once the physical tooling is cut, those decisions become brutal, permanent realities. Powered by Depix Design Intelligence.